topics related to the partial derivatives. Now we will discuss the implicit differentiation. Maybe you know about implicit differentiation in calculus 101, that how you can find the implicit differentiation of any function. So here the implicit differentiation is a little different because the function is involved different variables. Implicit differentiation. This is the same exercise which we left in the last class, which is 13.5. So there is a theorem which we use for finding the implicit differentiation. Okay, so what is the theorem? That if you have any function, for example, if the equation f of xy is equal to c defines y implicitly as differentiable function of x if the partial derivative of a function with respect to y should not equal to 0, then the implicit differentiation have dy over dx that is equal to negative times partial derivative of the function with respect to x whole divided by partial derivative of the function with respect to y. Okay, so you can also write that is minus times partial derivative with respect to x divided by partial derivative with respect to y. So there is a condition that the partial derivative with respect to y should not equal to 0. Okay, and there is a negative sign with the partial derivative. So this is the implicit differentiation. If you have any equation is given to you and you can write that equation implicitly as a function of y as a function of x, so you can apply this formula for finding the differentiation. Okay, so now I will give you one example so it will be clear that how we can apply this formula on any equation. For example, x power 3 plus y square x minus 3 is equal to 0, then find dy over dx by using the implicit differentiation formula. Okay, by implicit okay. Now what is the formula for implicit differentiation? That dy over dx that is equal to negative times partial derivative with respect to x divided by partial derivative with respect to y. Okay, so this is the formula for the implicit differentiation. Now we need the function. Okay, so function we can get from this equation. What is the equation? That you can write f of xy is equal to x power 3 plus y square x minus 3. Now what is the partial derivative with respect to x? Anybody can tell me what is the partial derivative with respect to x? What is the partial derivative with respect to x? 3x power 2 plus y square, and what is the derivative of x? That is equal to 1. And what is the derivative of 3? That is equal to 0. So the partial derivative with respect to x is equal to what? 3x square plus y square. Similarly, you can find the partial derivative with respect to y. What is the partial derivative with respect to y of this function? That is equal to 0 plus x. And what is the derivative of y square? That is 2y minus 0, which is equal to 2xy. Substitute this value and this value in the formula. What you will got, that dy over dx, that is equal to negative times 3x square plus y square divided by 2xy. So this is the implicit differentiation of this function, okay, of this equation. Is this clear? That what you have to do, you have to just simplify the function, okay, in terms of x and y, and then find the partial derivatives. Partial derivative with respect to x and partial derivative with respect to y, and substitute in the formula. And this is the formula, okay. So now if you have uh, an equation for more than two variables, so how you can apply the implicit differentiation on that? So there is a different formulas, and there is a theorem that when you have the equation of three variables, for example, if the equation is like this one, that you have a function of three variables x, y, and z, that is equal to c defines z implicitly as a differentiable function of x and y both if the partial derivative of the function f with respect to z should not equal to 0, then you have two formulas for the implicit differentiation. One is with respect to x, partial derivative of z with respect to x, and another one will be the partial derivative of z with respect to y. So with respect to x, that will equal to minus times partial derivative of f with respect to x divided by partial derivative of f with respect to z. The second one is minus times partial derivative of f with respect to y and the partial derivative of f with respect to z. Okay, so this is the formula for finding the implicit differentiation with respect to x and with respect to y when you have a function of or equation of three variables. Function or equation of three variables. Okay, so now I will give you one example, so that you know that which type of equations are given to you when you apply the implicit differentiation for with respect to x and with respect to y. For example, consider the sphere which is given by x square plus y square plus z square is equal to 1. Okay, and you have to find the partial derivative of z with respect to x and z with respect to y at the point 2 by 3, 1 by 3 and 2 by 3. Okay, you have to find the partial derivative, and after that you have to substitute this point. Now for partial derivative with respect to x, z with respect to x and z with respect to y, we have a formula. Okay, so what is that formula? That partial derivative of z with respect to x, that is equal to minus times partial derivative of f with respect to x divided by partial derivative of f with respect to z. Okay, this is the first formula. Now the second formula for the partial derivative of z with respect to y is equal to negative time partial derivative of f with respect to y divided by partial derivative of f with respect to z. Okay, so these are the two formulas. Now the equation is given in terms of x, y and z. So you can write a function f of x, y and z that is equal to x square plus y square plus z square. Okay, so from that you can easily find what is the partial derivative of f with respect to x. What is the partial derivative of f with respect to x? 2x. Very good. What is the partial derivative of f with respect to y? 2y. Yeah. What is the partial derivative of f with respect to z? 2z. Okay, so substitute these values in the formula. Okay, in this formula what you will got, that the partial derivative of z with respect to x, that is equal to negative times partial derivative of f with respect to x, that is 2x, divided by partial derivative of f with respect to z, that is 2z. Okay, so that will give me minus negative of x divided by z. Similarly, you can find partial derivative of z with respect to y. Partial derivative of y with respect to f with respect to y, that is 2y, negative of 2y divided by 2z, that is equal to minus y over z. Now what is given at the point, this point you have to find the partial derivative. This you calculate. These are the values you calculate with respect to x and with respect to y. Now you have to substitute these point, okay, in the partial derivative. So I will write in the next page that the partial derivative of z with respect to x is equal to minus x over z, right? We calculate minus x over z, and the partial derivative of z with respect to y, we calculate that is minus y over z. Now you have to substitute this point 2 over 3, 1 over 3 and 2 over 3. So the partial derivative of z with respect to x at the point 2 over 3, 1 over 3 and 2 over 3 is equal to minus 2 over 3 divided by 2 over 3, which is equal to minus 1. Okay. Similarly, you can find the partial derivative of z with respect to y at point 2 over 3, 1 over 3 and 2 over 3, that is equal to minus 1 over 3 divided by 2 over 3. 3 and 3 cancel, which is equal to negative of 1 divided by 2. So this is the implicit differentiation. Okay, at any point you can find the implicit differentiation. Is this clear? Okay. Now, the next topic is 13.6, which is about the directional derivatives and gradients. Okay. 13.6 is directional derivatives and gradients. Okay. So first we will discuss about the directional derivatives, and then we will discuss what is gradient. So what is directional derivative? Directional what is the definition, or you can say what is the equation for finding the directional derivative. So for example, if you have any function, if I say if you have any function of two variables, let me discuss for two variables first and then three variables. That for example, if you have function f of x y is two variable function, is differentiable at x naught y naught, and if u is any unit vector, okay, u1 plus u2 is u is any unit vector, is a unit vector, then directional derivative du of the function at point x naught y naught exists and is given by in this form. Du represents the directional derivative of the function at point x naught y naught, which is equal to the partial derivative of the function at with respect to x at point x naught y naught, multiply with the first component of the unit vector u1 plus partial derivative of the function with respect to y at point x naught y naught, multiply with the second component of the unit vector. So this is the formula, or you can this is the equation which is used to find the directional derivative of any function. Okay, so for directional derivative you must need a unit vector. For any two-dimensional function there must be a vector of two dimension. So you have to represent the first component u1 and the second component u2. Okay, and you need the partial derivative with respect to x and partial derivative with respect to y. This is the formula for the two-dimensional case when you have a function of two variables. Now I will explain the formulas, both formulas for two and three dimension, and then we will discuss the examples. Now, if you have the three-dimensional function, the function with three variables, so what will be the formula? Okay, so if you have the function f of x, y, and z, this is function is differentiable at the point which is x naught, y naught, and z naught. And if you have any unit vector, u is a unit vector which is equal to u1i plus u2j plus u3, k is a unit vector, then the directional derivative. The directional derivative can be represented by du of the function at point x naught, y naught, and z naught, which is equal to the partial derivative of the function at point x naught, y naught, and z naught multiplied with the first component, partial derivative of y at point x naught, y naught, and z naught at point u2, plus partial derivative with respect to z at point x naught, y naught, and z naught multiply with the third component. So this is the formula when you have the function and the unit vector in 3 dimensions. Okay, so I will now give you one example that if the function is given and the unit vector is given, how you can find the directional derivatives. Okay, so see the question, that example. Find the directional derivative of the function f of xy, which is equal to xy at point 1 and 2 in the direction of the unit vector why it's not written in the direction of the unit vector, which is u is equal to square root of 3 divided by 2i plus 1 divided by 2j. Okay, unit vector is given, function is given, point is given. This is the function, this is the point, and this is the unit vector. It's given. Now you have to find the directional derivative. So you should know what is the formula for the direction derivative. First, see the function is 2 variable function or 3 variable function. Okay, so the function is 2 variable function. Then du of the function at point x naught, y naught, that is equal to partial derivative of the function with respect to x at point x naught, y naught multiplied by u1 plus partial derivative of the function x naught, y naught multiplied by u2. Okay, so this is the formula. Now what we need the partial derivative of a function with respect to x and with respect to y. So what is the partial derivative of the function with respect to x? This is the function xy. What is the partial derivative with respect to x? What is the partial derivative with respect to x? Only y. Okay, so if you substitute the value of the point, which is the point 1 and 2, that will give me 2. Okay, similarly, what is the partial derivative with respect to y? That is equal to x. So if I apply the point in that, that will give me 1. So substitute in the formula, what I will got, that du of a function at point 1 and 2, that is equal to, what is the partial derivative with respect to x of a point which is equal to 2, u1. U1 is square root of 3 divided by 2 plus partial derivative of y at point, which at point 1 and 2, this is equal to 1, and u2 is equal to 1 divided by 2. So simplify, you will get this 2 cancel with this one, square root of 3 plus 1 divided by 2. So this is the directional derivative. Okay, is this clear? You must know the formula. You must know the formula. If you don't know the formula, it will be very difficult for you to calculate the directional derivative. Okay. Let me give, when there is no unit vector is given, how you can calculate the directional derivative. Okay. So for example, there is a question that find the directional derivative, find the directional derivative of function f of x y is given, which is equal to e power x and y at point -2 and 0 in the direction of the unit vector that makes an angle pi divided by 3 with positive x-axis. Okay. Now, in this case, is there any unit vector is given? No, unit vector is not given. So how you can solve this one? Solution. So we know that unit vector is equal to the x component I plus y component j, right? In general, unit vector represents like this one. So when we talk about the polar coordinate, x represents the r cosine of theta and y represents the r sine of theta. Okay. When you talk about the unit vector means r is equal to 1. So what will be the unit vector that will give you cosine of theta I plus sine of theta j. Now what is the angle given? Angle is pi by 3. So cosine pi by 3 I plus sine pi by 3 j. So simplify it, you will get cosine pi by 3, that is equal to 1 divided by 2 I, and sine pi by 3, that is equal to square root of 3 divided by 2 j. Okay, so now we calculate the unit vector. In this unit vector, u1 is equal to 1 divided by 2, and u2 is equal to what? Square root of 3 divided by 2. So you have to use this, unit vector. Okay, is this okay? How we calculate the unit vector? If in general form, you can write the unit vector in x and y, and you know that x is equal to r cosine of theta, y is equal to r sine of theta. So we talk about the unit vector. So r is a vector. So when you talk about the vector, it is unit vector, so it means its length is 1. So 1 multiplied by cosine of theta means cosine of theta. So put the angle and you will get the unit vector. Now, what is the formula for the directional derivative? The directional derivative formula is du of the function at point x naught y naught is equal to partial derivative of x at point x naught y naught multiplied by u1 plus partial derivative of y at point x naught y naught multiplied by u2. This is the formula. Now, what is the partial derivative of a function with respect to x? This is the function. The partial derivative with respect to x is xy and multiplied with y. Okay, so if I substitute the point, what is the point? Point is -2 and 0. So that is equal to e power -2 into 0 multiplied by 0. So multiply by 0 means everything will be 0. Similarly, you can find the partial derivative with respect to y, that is equal to e power xy multiplied by x. So if you put the value -2 and 0, that will give you e power -2 into 0 multiplied by -2. E power 0 multiplied by -2. E power 0 is 1, so that will give you -2. Now substitute these values in the formula. So when you substitute these values, you will get du of the function at point -2 and 0. What is the partial derivative of x? That is 0 multiplied by 1 divided by 2 plus what is the partial derivative of y? That is -2. And what is u2? u2 is square root of 3 divided by 2. This 2 cancel with this one. So the directional derivative of a function at point -2 and 0, that will give you minus square root of 3. Okay, is this clear? Okay, so now we have two examples, in which in first example that unit vector is given, so it is very easy. In second example, we find the unit vector from the angle. Now in third example, if only vector is given, so how you can calculate the unit vector? Okay, so the third example is that example, find the directional derivative of the function. For example, the function is given f of x y is equal to x square y minus y, and now this is the function of three variables. Okay, so let me remove and write again. Y z power 3 plus z. Okay, at the point -1, -2 and 0 in the direction of in the direction of the vector A, which is equal to 2I plus j minus 2k. Okay. Now this is only vector is given. Anybody know how we can find a unit vector from a vector? Anybody know? A unit vector square root. Okay, this is also somehow some part. Unit vector is equal to a vector divided by its magnitude. You remember this one? A unit vector is equal to a vector divided by its magnitude. So you can easily find the unit vector 2I plus j minus 2k divided by what is the magnitude of A, that will give you 2 square plus 1 square plus minus 2 whole square. So which is equal to 2I plus j minus 2k divided by square root of 9, which is equal to 2I plus j minus 2k divided by 3. So what will be the unit vector? The unit vector will be 2 by 3I plus 1 by 3j minus 2 by 3k. So this is the unit vector. In this unit vector, u1 is equal to 2 by 3, u2 is equal to 1 by 3, and u3 is equal to negative of 2 by 3. Okay, so unit vector we calculated. Now we have to find the write the formula. Okay, and then write the formula and then solve accordingly. So this is how many variable function? This is 3 variable function. Okay, so the directional derivative formula at point x naught, y naught, and z naught is equal to the partial derivative of a function with respect to x at point x naught, y naught, and z naught multiplied by u1 plus partial derivative of y at point x naught, y naught, and z naught multiplied by u2 plus partial derivative of z at point x naught, y naught, and z naught multiplied by u3. So this is the formula. Now what is the partial derivative with respect to x? What is the partial derivative with respect to x? That will be 2xy only. Okay, so if you substitute the point partial derivative of x at point 1, minus 2, and 0, that will give you minus 4. Okay, similarly, what is the partial derivative with respect to y? That is equal to x square minus z power 3. So when you put the point 1, minus 2, and 0, that will give you 1. Okay, similarly you can find the partial derivative with respect to z, that is equal to minus 3y z square plus 1, and if when you substitute the point 1, minus 2, and 0, that will give you 1. Okay, so put in the formula, you will get du of a function at point x naught, y naught, and z naught is equal to minus 4, and u1 is 2 over 3 plus 1 multiplied by 1 over 3 plus 1 multiplied by minus 2 over 3. So you can simplify like this one, that is equal to minus 8 over 3 plus 1 over 3 minus 2 over 3, which is equal to 3 minus 8 plus 1 minus 2, which is equal to minus 9 over 3. So this is the answer, minus 9 over 3. Okay. Minus 9 over 3. So this is the answer. Is this clear? That how you can calculate if you don't know the unit vector, you have to first calculate the unit vector, and then you have to apply on the formula. Okay, so this is all about the directional derivatives. So now the next topic is gradient, direction derivatives and gradient. Gradient is basically the vector. Gradient is basically the vector. And how we can calculate the gradient of any function. So when you have two dimension, I will discuss the two dimension and three dimension. A part, it's two dimension, that if you have any function f of xy is a function, then the gradient of the function f is defined by this formula. You can represent delta of a function f of xy, which is equal to partial derivative of f with respect to xi plus partial derivative of y with respect to j. Okay, so this is two dimension. When talk about three dimension, that if you have any function x, y, and z is a function, then the gradient of the function is defined by delta of a function x, y, and z. You have to first calculate the partial derivative with respect to x, I, plus partial derivative of y, j, plus partial derivative with respect to z, k. So this is the formula for the gradient. Okay, these are the formula for the gradient. So I will give you one example. So it is just very simple, that you have to just calculate the partial derivative and write like this in a vector form. Okay, so for example, if the question is given that find the gradient, find the gradient of the function f of x, y, and z is given, which is equal to y square z tangent of power 3x at point pi by 4 minus 3 and 1. Okay, now for the gradient we need the partial derivative of f with respect to x, with respect to y, with respect to z. What is the formula? You can write the formula that the gradient of any function Okay, for example, if this is a function of x, y, and z, that is equal to partial derivative of xi plus partial derivative of yj plus partial derivative of zk. Okay, so now if they say that you have to find the gradient at this point, then you have to substitute the point. Now what is the partial derivative with respect to x? What is the partial derivative with respect to x? Anybody can tell me what is the partial derivative of this function with respect to x? That will be y square is same, z is same. What is the derivative of tangent power 3? Tangent power 3 derivative is 3 times tangent power 2. Okay, and what is the tangent derivative? That is secant square x. Okay, so partial derivative with respect to x is equal to 3 y square z tangent of square x into secant square x. Okay, now substitute the point partial derivative of x at point pi by 4 minus 3 and 1, that is equal to 3 times minus 3 square into 1 into tangent of pi by 4 whole square into secant of pi by 4 whole square. So 3 multiplied by 9 multiplied by 1, tangent pi by 4 is 1 and secant pi by 4 is square root of 2. So that is equal to 27 multiplied by 2, that is equal to 54. Okay. Similarly, you can find the partial derivative with respect to y. Partial derivative with respect to y is 2yz tangent cube x. So if you substitute the point pi by 4 minus 3 and 1, you will get 2 multiplied by minus 3 multiplied by 1 multiplied by tangent of pi by 4 power 3, which is equal to minus 6 multiplied by 1, that is equal to minus 6. Okay, similarly you can find the partial derivative with respect to z, that is equal to y square tangent power 3x. When you substitute the point pi by 4 minus 3 and 1, so that will give you minus 3 whole square tangent of pi by 4 whole square, which whole cube, that is equal to 9 multiplied by 1 is equal to 9. So when you substitute in the gradient of a function at point pi by 4 minus 3 and 1, that is equal to 54i plus minus 6j plus 9k. So this is the gradient. Okay, understand? If the point is not given, you have to write the direct like this one with respect to z k. Okay, so if point is given, you have to substitute the point. So this is all about the gradient. Now 10 minutes break and then we discuss a small topic which is tangent plane and normal vectors.